In this next section, we will open up our application and connect to the chassis and create clients. So let's start with Wave Apps. And we're viewing the screen of the computer where Wave Apps has been installed and Wave Test has been installed. So the opening screen here shows us all the different application suites we have to choose from. Let's start with a simple one, packet loss. So we chose packet loss, and now the concept is that we're going to work our way down the left-hand side of the screen here, filling out information as we go. So the first thing that the application asks us to do is to find ports. By doing that, we need to point at a chassis. So we'll put in either the host name or the IP address of the chassis that we're connected to over Live Network. 192.168.254.46 is the chassis that I'm connected to. So as soon as we either hit return or press connect, we now see the chassis and we see the cards that are available. This is a WT20, so there are 2 cards available. If this was a WT90, we might see multiple cards and we might see multiple ports within a card. And the ability then to choose for this application which cards pertain to this application. So you have to check the box next to the card that the application is going to take control of. So first we check this 802.11ac card, and we notice that on the right hand side the menu over here changes that to be appropriate to the choices that come with a Wi-Fi card. So we can select the band, whether it's a 2.4, 4.9, or 5 gigahertz. This is what frequency we are going to tune the radio on that port to. And remember that radio on a given port can only be tuned to one channel at a time. So if we were doing channel 1, we would choose 2.5 gigahertz and we would choose primary channel of 1, right? We can choose, if it's an 802.11n or AC system, we can choose whether the secondary channel is placed above, below, or defer means listen to the beacon of whatever it is you're going to connect to, whatever access point you're going to connect to, and set the secondary channel based on the beacon information. That is what most people do most of the time unless you're doing negative testing. Now we do have another choice here that I will point out to you called the channel scanner. The channel scanner is a really useful device because what it does is gives you the ability to use that port card to scan every channel and see that only the access point that you are connected to is present. So we're going to be doing a 5 gig test. So I'm going to select only 5 gig channels. I could have chosen to scan every channel, channels 1, 6, and 11, all 2.4, or all 5 gig channels. We're going to just scan the 5 gig channels. And let me make this a little bit bigger so we can see what's going on here. And I'm going to scan on the current port. So notice the port now is being directed by the application to do a channel scan and looking for beacons on each one of the 5 gig channels, and it's going to work its way along, and we see that progression down here. See, it's scanning on the port, and once it finds a beacon on a given channel, it's going to leave information behind that says it found something. Okay, so now it's scanned on all of the different channels, and here it found one beacon on channel 153. So if we select that, we can see what the SSID is, what the BSSID is, what its received signal strength at the front panel of the product is, security, etc. So this is a great way to scan all of the channels and see what it is the blade card can hear. So if you have your access point in an enclosure and you think you've got good RF isolation and you're going to do some testing on channel 153, here's a way to go through the bands and see, is that really true, or are there other access points that are leaking into the test setup? Now if we choose Okay, so we've now found this, and we can right click, we can go to the channel where we found this, and we can right click and select set channel on port. So now when we move out, it will take this information and fill in the band and primary channel information and do channel scan for us. So that's using the channel scanner. If we ever change the channel here, what will happen is the port will be forced to do a rescan to find out what beacons are available. There was nothing on channel 136. So we'll go back to 153. The system will scan, and there we find our SSID. We're using a Netgear access point in the BSSID. Okay. The other things I'll point out here is that at the bottom you see where it says include hardware log in the download. This is the place where if you want to do a Wireshark packet capture, this is where you instruct the application to include this card's packet capture in the download. So later on we will do save a hardware log after a test. When you select that option, only the cards that have this box checked are going to have their packet captures pulled in. This is to allow you to run rather large tests, but not necessarily have to pull in the capture logs from every card. Right? So we'll turn this feature off for now. High performance will be explained at a different time. On card 2, that is our Ethernet card. So we'll select him, and we can set conditions over here. Most of the time we leave it on auto negotiate, but if you wanted to you set it to some manual speed, you can do that over here. And again, include hardware logs and download is a choice. So now that we have the port cards chosen, selected by the application, we'll go set up clients. Now this page and the port page will be the same in all of the different applications. So once we've set up our ports and we've set up our clients, we can move between different applications and never have to come back to these pages unless there are specific changes we want to make. Let me go through the basics of setting up clients, and we'll come back in another session and do more advanced things. So here we have a row, and this represents a client group. In the application tests for Wave apps, what you tend to need to do is to set up a Wi-Fi and an Ethernet client or client group, depending on if you want more than one client. You need client groups established on either side of the device under test, which is typically an access point or an access point plus its controller and switch. So simplest thing we can do here is create one group called, let's say, Wi-Fi, right? We tell it what type of a card it's attached to. In this case, it's 802.11ac. And once we've done that, since we have an AC card selected, it'll fill in everything that it knows. Now, if there are multiple 802.11ac ports that have been selected on the port page, we would get a drop down here where we could choose which port this client group is going to be assigned to. If there are multiple SSIDs that have been seen on a given port during a scan, we would get a drop down here so we can choose between these SSIDs. If for a given SSID there are multiple BSSIDs that were found during a port scan, that would show up here in this drop down. So what you're allowed to do here then is to very specifically assign a client group to a port, an SSID, and a BSSID. So this is how you can build tests where you have known clients, numbers and configurations connected specifically in the way that you want them, right? It's not randomized, it's not accidental and non-repeatable, it's very deterministic. So we have also the ability to choose how many clients this group will represent. So in this case, we'll leave it be 1, but we could set this to 100 or up to 500 for a given port, right? So that just means that we're going to instantiate 100 clients. Their base IP will increment by 4 and their MAC address will also increment by 4 as we go along. So we're going to just have one client for now. And now let's move through the pieces that are on the bottom of the page here. We're going to enable DHCP. The access point that we're testing has a DHCP server in it, so we'll let it take care of that. It's an 802.11ac access point, so let's select 802.11ac. If we select 802.11n, the choices you get are appropriate for 802.11n. In this case, it's 802.11ac. It's 3 spatial streams, 80 megahertz. So we choose our signal bandwidth of the client, and we choose the data MCS index for transmission of that client. Now, this is important to remember. This is what the client is going to advertise that its maximum capability is when it associates with the access point. And then all data packets that are transmitted by the Waveblade by this client will be at this phi rate. There is no rate adaptation that occurs within these applications. And so often you have customers who have set their signal power very low, or they have configured a client type here that's not compatible with the access point, and they'll complain that in the upstream direction, no frames were ever received, no frames were ever transmitted. That's because whatever you set up here is exactly what that client is going to use for transmitting data. It does not rate adapt. So we're going to set the short guard interval. We've enabled AMPDU and our AMSDU aggregation. We could choose what channel model to use here. We'll start out with bypass, all right? And we have 30 dB of attenuation physically in between the blade card and the access point. So we'll leave this transmit power at -36, that's fine. We can also choose to set up whatever security type and the credentials that go along with them. We're currently running open, but this is where you would set up any security type that the access point requires. And under advanced options, we selected gratuitous ARP by default. That just helps the network learn what the client's characteristics are. We can choose CTS to self, we can change the probing, we can add keep alive frames, and we'll come back and talk about those at another time. Now let's add an Ethernet group. In the Ethernet group, we'll call ETH. We need to describe what interface type card it is associated with. That would be obviously an Ethernet card, and we fill in the rest of the information. We will enable DHCP, and if there's VLAN tagging, any security that's associated on the Ethernet side, or if we want to change anything about the MAC addressing, that can be done there. But simply put, you can leave these things in a default state. Get yourself a Wi-Fi and an Ethernet client group built with one client in each, and now you're ready to run your first test. So this completes the session on connecting to the chassis,